So I've been working a few years at Reactor as a software developer, and sometimes we've given this book out to new colleagues when they join the company called Leadership and Self-Deception, which talks about the ways in which we sort of put ourselves in these boxes in which we deceive ourselves, and we think of other people not as people, but as sort of obstacles and enemies and things that are getting in our way. So I rewrote the book, JavaScript and Self-Deception. And I thought we could talk a little bit about the ways in which we deceive ourselves, both when we write JavaScript and also when we talk about JavaScript sort of from an outside perspective, and the ways in which JavaScript is good and bad. So there's this argument that you hear quite a bit that goes kind of like this. JavaScript sucks. It has weird equality handling, right? So in this example, an empty array is true, null is false, or an empty array is false, that's true, null is false, that's false. It has weird number handling. 0.1 plus 0.2 it's almost 0.3, you know, we're trying, it's close. It has weird type coercions. If you add the string 2 to 2, you get 22 as a string. If you subtract the 2, you get 0 as a number. It has a weird this. So you call the same function 2 different times, you'll get a different this within the function depending on how you called it. Depending on what's on the left side of the dot, or if there's nothing on the left side, then it defaults to window, unless you're running in Node.js. It has weird scoping. If you forget to use var or const or let, then things will get defined in global scope by default. It has weird hoisting. If you define two functions in slightly different ways, then one of them will get magically sort of hoisted to the top of your module, except it's not a module because JavaScript doesn't have modules. It has two types of null, right? It has null and undefined, just to make things more difficult. It has not a number and infinity. It has no modules by default, except in sort of newer versions of JavaScript. It has no types. Everything is mutable. It has callback hell. So JavaScript sucks, right? No. So this is basically a straw man argument. And this might be the original straw man here that's getting blown up in this picture from Wikipedia. So there's an argument you could make there, but I think it's much more subtle than the argument you hear most of the time. Because most of those problems, they aren't really real problems in practice. You run into a lot of these things quite rarely. It's not really a problem except when you're trying to learn JavaScript and you're wondering what the heck is going on. And most of these have easy, sort of widely adopted solutions. So basically, this is looking at JavaScript at its very worst and saying, look, JavaScript sucks. But so what if we take sort of the opposite approach? If we do sort of the steelman argument for JavaScript? JavaScript at its best. And so these are my opinions. This is how I think you should write JavaScript. You may have your own opinions. They might also be good, but you're welcome to use these ones. So how to write JavaScript? Use a build tool, Webpack, Browserify, whatever it is. You get modules, that sort of thing. Use a linting tool, which gets rid of most of your issues around weird equality rules and things like that. Don't use double equals. Use the triple equals. You kind of have to know truthiness just because you do run into that stuff. Don't use var. Use const and let. Don't use this. You don't need it. You can pass arguments to functions. Don't use classes. You don't need classes. Pass arguments to functions. Unless you're using a library that uses classes, then you use classes. But you don't need to write classes. You use futures or promises. Callback hell is not a thing in JavaScript, or it shouldn't be, because everyone who's doing asynchronous requests is using something. Promises or lazy futures like in Fluture. Use a functional library. Use something like Ramda. Use FPTS. Use these kind of tools to make it easier to do data transformations. Use validation. Use something like JSON schema or something based on that, or IOTS if you're using TypeScript. Use types. I don't consider TypeScript and Flow to be really different languages. It's just types on top of JavaScript. Use pure functions. Use the ternary operator. Don't do side effects. Use immutable data. If nothing else, use it by convention. But otherwise, you can pull in libraries like Mutable.js or Mori or this sort of thing. Or you could sort of take the easy route. You could just use PureScript. If we look at, so PureScript is a strongly typed functional language that compiles to JavaScript. How do you write PureScript based on this sort of listing? Use the build tool. Well, just use the default. Use Bodil's thing. You download it. You use it. It's what most people use. Use a linting tool, well, if you like. It doesn't really have the problems that you really need a linting tool for in JavaScript. Don't use double equals. Well, it works exactly as you would expect. So you can forget about this rule. You don't need to think about it. Understand truthiness. It also works exactly as you would expect. Forget about it. Don't use var. It doesn't have variables in the same way. It works how you would expect. Don't use this. There's no this. Don't use classes. No classes. Use futures or promises. Use af. It's like lazy futures, but a little bit better. Use a functional library. Well, it's sort of functional by default. It's all built in. It's all functional. Use validation. Well, it's also kind of built in by default. Things are validated, at least on the type level, basically by default, and there are lots of tools built up around that. Use types. Built in. Strongly typed. Use pure functions. They're all pure. It's built in. Use immutable data. It's immutable by default. So basically, out of most of the things I've learned in the past few years about writing JavaScript, I could have skipped all the effort and just learned PureScript. And that would have been enough. You just write PureScript. And that doesn't mean it's good code. You can still write crappy PureScript. But we've raised the level. You can follow these rules to write the best JavaScript you can write, or you can sort of start at that level and work upwards. And that's basically the argument. That's the talk right there. But if you want to hear the longer story, I can talk a little bit more. But so what I'm going to talk about now is data, because we use data all the time. We take in data, we transform data, we push out data, that sort of thing. Fear, because we're all afraid. We're afraid of our stuff breaking. We're afraid of taking down servers in production, that sort of thing. Trust, because we want to trust the code that we write. We want to trust that what we write actually works and will work in the future, and we can refactor it if we need to make it work later for other things. JavaScript, because we have to deal with JavaScript. Quite a few of us sort of have to deal with it at some level. And the path beyond. So if we look at JavaScript, at one example, what does the data look like in JavaScript? What is sort of the shape of the data? So by default in JavaScript, you do this thing where you kind of pretend it's what you want. So here in our example, we fetch something over the network. We fetch a user by ID. We get back a user, and we say, yes, I've got my user. This is great. And then later, we need to do something with that user. Maybe we display its name, so we render its name. And we're like, all right, it's got a name. We're doing well. And you're trusting that the other systems that you work with will return the data in the correct format. And this might work fine. If you wrote the backend, you're like, well, I'm pretty good. I know what I'm doing. I trust these guys I work with. Maybe that's fine. And you're trusting the other developers that you work with. You're trusting also that they're not going to change the user within your code base. But then, after a while, the fear starts to creep into your code base. And this is what fear looks like in a code base. So you get your user, and now there's a little bit of uncertainty. You're not quite sure. Maybe it doesn't have a name anymore. Maybe the users are coming from different places now. So you check that. And you throw an error, and you check another thing. And you do this in sort of an ad hoc way. And then later down the line, you're trying to render your user, and you're not quite sure if it still has all the things you had on it, because things changed in the meantime. But so one way you can sort of try to alleviate this fear is to pretend really hard. So you take TypeScript, and you say, all right, now I fetch my user by ID, and I get back a user, but now it's a capital U user. If you notice up here, it's got a capital U. That means it's different, right? Well, you're not actually checking the user at that point. In the default case, you're saying we got a user, and now it has a type. It has an ID and a name and an email, and that's what we're expecting to get here. But then after that point, TypeScript kind of helps you verify that, at least within your code base, you're using a user as a user, and you're not doing weird things with it. So it gives you that sort of internal consistency, but it doesn't help you with the outside world. You're still trusting other systems when you do this. And then you're still trusting the developers when your project to write correct types, which can be a problem as well. You're also trusting that within TypeScript, none of the types in sort of the path of things you're doing have any type, which means basically it doesn't have a type. We're disabling type checking within this path of our code. And so you might also want to introduce validation to be able to handle sort of external data. You get your external data, you validate your user, then you throw an error then. And basically this idea of failing quickly if the trust breaks down. And you might use something like JSON schema for this, but then you have to write out these long sort of objects for validating your JSON, and these things get sort of laborious to write, and it's hard to maintain, and in the end you're trusting developers to not be lazy and not update these things and this sort of thing, and it's going to be difficult. So another way you could do it is do sort of validation and use TypeScript, right? And then you get this sort of you're still trusting that your types are correct within your code base, which I might touch on a little bit later. And you're trusting other developers to write correct types and your types to not have any, and that sort of thing. But you get more trust in your code. And if you do this with something like TypeScript JSON schema, you can just write the TypeScript type. And then there's a little bit of boilerplate around it in the first time, but then after that, you just write the types, and it generates a validator for that. Or if you use something like IOTS, you can do that in sort of the other direction. You write a validation object, and then you get the type from that. So you can only write it in one place, and it's easier to maintain. But so what does this same example look like if we look at it from the PureScript perspective? So the great Irish playwright and poet, Oscar Wilde, is also the greatest developer of the Victorian age, unbeknownst to many. So Oscar Wilde tweeted the other week, or some time ago, I mean, that a good language will always stab you in the front. PureScript stabs you in the front. So if you look at the same example from PureScript, here we're basically doing the same thing as before. We have this load and render a user function on the bottom, which calls to load the user. We fetch some user over the network. Then we do this read JSON to parse it into a user. And if we have errors, we log the errors. Or if we have a user, we render the user. So it basically looks like what we ended up doing on the JavaScript side. You have this sort of validation by default. It has this call to read JSON there, which checks to see that the data you're getting is the type that we wrote up there. It's a user with an ID and maybe an email, and it has a name that's a string. And you have sort of within your code base, you have strong types. You don't have null or undefined. You don't have any weirdness. The types are just whatever the type definition says. And you don't need to think about it anymore. So you can trust that the data within your code base has the shape that you expect it to have, and it'll stay that way. And the boilerplate around that validation bit is this. You write your type, like you do anyway, and then you call read JSON, user string. And in a lot of simple cases, it'll be just like this. So you sort of get this validation part of it for free. So another example from the JavaScript side. How does the data change in JavaScript? So by default, the data just sort of changes willy-nilly. You change things. You take in a document in this function that you need to format. And you take in some source, and you just change your document. You convert the date while you're doing it. Maybe you set it to null, and you set this source on your document. And this might be fine. It might be fine in small cases, and this is sort of a cherry-picked example in a way, but it's meant to be more of a representative example than a cherry-picked example. Because you see this a lot, and the problem here is that the flow is really hard to follow. You take in this document, and to understand what the document looks like, you have to follow it at every point throughout this function. And this gets worse and worse as your code gets larger. And then there's also sort of this fear that can come up, especially if you're doing it highly concurrent processes. Now, what if this document's used elsewhere? And now we've just changed it. And now we've betrayed the trust of whoever wrote the code that does the other part, which might have been you the other week. You turn to types, but these types won't save you, right? So here's the same function. And then below, we have a second function that has exactly the same type in TypeScript. It takes in, you look at the type, it says it takes in a document, and it takes in a string, and then it returns void, which means it does nothing, right? It's good. It does nothing. But then if you look at the bottom type, or the bottom function, then we're launching a rocket, and we're removing your file system while we format our document. But they have the same type. But so one way you might get around this is to do this sort of pretend immutability, right? You're working with experienced people, maybe. You do this thing where, you're not doing weird things. Instead of changing data, you create new data, or you copy things where you have to. And so here we take in a document and source, and instead of mutating the document, we just return a new document that has new stuff. We're not mutating data. We're not deleting the root directory. We're not launching any rockets. And this can work pretty well, depending on your team. You can get pretty far just by kind of trusting that everyone follows these sort of norms. But you might want something stronger. So you could turn to libraries, which is like pretending really hard. So if you use something like Ramda, then it has, for doing sort of functional data transformations, by default, it won't mutate the data that you're using. Or if you use something like Immutable.js, then as long as you're using Immutable.js's data structures, you can't actually mutate those data structures. But you have to convert back and forth between other JavaScript structures. And both of these sort of depend on other developers using these tools. The convention has to be pervasive within your code base for this to really make sense. And there are other tools you could use to do this. You could use partial lenses from Bessa here in the middle. Or you could use Sanctuary or Mori or underscore Lodash, these kinds of things. But you're sort of shifting, you still have the trust on the developers. You're trusting the team to use these tools correctly. So if we look at the same example again from the PureScript side, another quote from Oscar Wilde. "The bravest developer among us is afraid of himself. The mutation of the data has its tragic survival in the self-denial that mars our lives." I think he was a man ahead of his times. So this same example in PureScript looks pretty similar in the end to our sort of functional conventions example in JavaScript. So here we take in a source document and a string, and we return a document. And the thing we return is just another record that we create from there. And if we have a date, we might convert the format on the date. And basically, it looks pretty similar to the thing you might have written in JavaScript anyway, right? But there's some subtle differences there. It can't actually mutate the data. If you look at the type, it takes in a source document and a string, and returns a document. It doesn't say anything about changing things. It doesn't say anything about mutations. It doesn't say anything about launching rockets. Right? It just takes in things and returns things. And those other changing it or launching rockets are not in the type. But suppose you actually do want to change it. You want to mutate this data. Well, then it looks like this. Instead of taking in a source document, we take in this mutable reference to a source document. And then instead of returning just another document, we return this effect, this EFF unit, which says we're doing some side effect, and we're not returning any other value. And it doesn't tell you necessarily what side effect you're doing, but it tells you that it's doing something. And you might decide later that you're not actually going to run this side effect. You might say we're going to build up this stream of effects, and then we'll run some of them, and we'll ignore the others. It hasn't actually run it yet. And we still can't do things like mutate our document just arbitrarily. It says it's a mutable reference to a source document, so you can only give it fields that are in the source document. And we can't mutate other things that aren't represented in the type as something that can be mutated. So suppose you actually do want to launch the rocket. You could do that too, But then again, it shows up in your type. Here we're returning a side effect. And then when someone else who uses this code that's to format a document might wonder why this is returning a side effect. Why do we need a side effect just to format this document? And if you really, really want to mutate it, maybe for performance, maybe for some other reason, you can cheat and do it in JavaScript. So you write this import declaration on the top to say, we'll use format document from the JavaScript side. Then in the JavaScript side, you just do whatever you want. And you can do that, but you probably don't want to. You lose all that trust that you gained. But if you need to, it's there. And so there are a few different examples here that I showed, but some tools in JavaScript that you can use for gaining trust that we talked about were optional types, validation, immutability, and then using these sort of functional transformation libraries. So I'm not going to talk about validation and functional transformation just because, even though you kind of get that by default in PureScript without thinking about it. But there are tools for doing it in JavaScript. It works all right. And you might need to do other validation anyway. But there are a few problems with optional types and with sort of functional programming in general. So optional types need this sort of skill and trust to be effective in JavaScript. And then basically, functional programming, at some level when you're doing functional programming, you have to choose between functional programming or types or JavaScript. You can pick two of those options. So optional types need some skill or trust to be effective, basically because they're optional by design. You can not use them. And so it depends on developers actually using these things. And you probably want to tighten up configurations. You probably want to make types not so optional in the end, if you want to actually be able to trust it. Or you just kind of use them here and there, but then you don't really get anything from it. And a lot of things are hard or impossible to type out in Flow or TypeScript. So this has gotten slightly better for some things, but a lot of these things are built in to the design of TypeScript or Flow, just because they're trying to maintain compatibility with JavaScript. And some things in JavaScript are just not typable. And the other issue with that, so for both of those reasons, you kind of need this trust in the team to actually use these effectively. And the other issue with that is that these problems come up even more when you try to use sort of functional programming techniques. If you use something like immutable.js, and you look at the types for immutable.js, it's littered with any types. So basically, every time you're choosing to use that style of immutability, you're deciding, I won't use types. And for Ramda, it's sort of a similar thing. Like lots of Ramda works fine with TypeScript, but then there are also a lot of parts that don't, where basically every time you choose to use that one convenience function, you lose your types. And the issue there is that in JavaScript, basically, types and immutability work best when they're pervasive, but JavaScript isn't designed around types or immutability. You can't make them pervasive except by convention, except by trusting sort of your team and saying, this is how we do things. So what if we look beyond JavaScript? Another quote from Oscar Wilde: "The longer I live, the more keenly I feel that whatever was good enough for our fathers is not good enough for us. In software, as in politics, the grandparents are always wrong," if I'm translating that correctly. And it's interesting because a lot of these ideas were actually written by our grandparents. Like our grandparents came up with these ideas many decades ago. But so, what if we assume that we have strong types and immutability in pure functions? What can we do with this? And how can we sort of take this further? I think the biggest thing for me with those is just this idea of sort of fearless refactoring. You can just forget about a bunch of things that you used to worry about. You stop worrying about unexpected data. You stop worrying about data just kind of changing underneath you. And you stop worrying about the stupid things that break the plumbing between your functions. And you can build these reliable, strongly typed UIs. You can say, what if we make our DOM strongly typed? Or if you want to do your CSS in sort of a strongly typed way, which makes it easier to maintain and easier to develop. Or you can do interesting things like generative testing, which this example is actually from Haskell. But it works the same way in PureScript. basically where you can say, I have a type here and a type here. So what if instead of writing a test that just tests one thing, like sort of one situation, you generate a bunch of tests with a bunch of data based on those types. And then you see that certain properties hold. So one interesting thing you can do with that, which I was playing with a few months ago, is if you're writing a distributed algorithm, and then you want to verify that the trace of the algorithm, basically the state of the algorithm at each step, fulfills certain criteria. Like in this case, if we have a shared resource that it only has one owner during that trace, and you can generate a bunch of these traces based on the type. And the big thing just being that you can stop worrying about the plumbing and start thinking about the real problems you have to deal with. Like the folks over at Awake Security, who have 20,000 lines of PureScript, presumably related to intelligent network security, or the guys at Slam Data, who wrote their front end in PureScript for doing visual analytics for NoSQL data, or the people at Foam, which have an interesting project building this secure location service on top of Ethereum that they wrote in PureScript, or this talk, which is about 900 lines of code of PureScript written on top of Reveal.js, just because it made it easier to do. Thank you.